Thank you very much for clicking on this video. In this video, we're going to look into aromatic hydrocarbons, and other name for them is aromates. Aromatic hydrocarbons are those hydrocarbons that have at least one benzene ring, just like this. They must have something that look like this. We have them to be benzene. We have methylbenzene, ethylbenzene, xylene. We have isopropylbenzene. These xylene are of three types. Okay, you can see them: orthoxylene, paraxylene, metaxylene, or we can even call the ortho to be 1, 2. Therefore, the word ortho represents 1, 2. The word para represents 1, 3, and the word meta here represents 1, 4. That is the three possible xylene we can get from aromatic hydrocarbons. The next thing could be, how did the structure come to be? Because if you look at the benzene has 6 carbon atoms and 6 hydrogen atoms. And if you understand the idea that every carbon has 4 unpaired electrons needed to be bonded with any other element, and if you try to share it with this hydrogen, it's going to be complicating. Therefore, a man suggested that this benzene is a ring, and the ring is in this form. And the man is named August Kekule. He's actually the person that proposed this imaginary structure of benzene. It has 2 sides which can be in this form. If you look at this structure, you notice that this started here. That is the bond. The double bond is found here, but the double bond is not here. It is just the same as, it's just like when you rotate this down here. Therefore, we are observing a resonance with these structures, which gave rise to a new structure we use as this. This is actually being taken because it is believed that there is a resonating structure with these two. Because if you carry this, put on top of this, you will look as if that there is a circle around it. The single carbon-carbon bond is 1.54. Let's check the double bond. This value is very, very small, but when we check the bond length of what we found in benzene, it is 1.39, which is neither of this or that. Therefore, the assumption of this resonating structure should be considered to be true of the imaginary structure of benzene. Therefore, let's look at the physical properties of benzene. It is a colorless liquid. It has an aromatic odor. It is insoluble in water but soluble in organic solvents. It is highly inflammable. It is toxic and carcinogenic. It has a melting point of 5.5 degrees Celsius and boiling point of 80.5 degrees Celsius. Okay, and let's look at the chemical properties. When we look at the combustion reaction of benzene, we observe that it burns in air with a sooty flame. Let's look at the substitution reaction. If, for instance, we use bromine here, we are going to use something like iron 3 bromide. Here at the same temperature, we're going to have bromobenzene here and hydrogen bromide or hydrobromic acid here. Although inside this place is not going to be acidic because this is not water. It is only when it dissolves inside water that we can say that this is acid. But here, I will just assume that it is hydrogen chloride. Please, let's take it like that. It is hydrogen chloride. Before we say something is an acid, there must be a little molecule of water in it. Since there is no molecule of water around here, therefore, this is not serving as acid. That is just serving as hydrogen chloride. The other one will be hydrogen bromide. I hope you get that. Continuation of the substitution reaction that is being found in benzene is nitration of benzene. Okay, when we use concentrated tetrodosulfate acid and we react it with benzene, we are going to have nitrobenzene if thiazonitrate 5 is present. That's the reaction. Okay, this is what happens. This is called benzene tetrodosulfate acid. Addition reaction of benzene. The addition reaction, benzene in the presence of nickel and hydrogen forms cyclohexane. As you can see, this is removing the double bond that is present in benzene to form a single bond. I said in my previous video that this type of reaction is actually applied in conversion of oil to margarine. Hope you get that. Okay, we still have other one, benzene reacting with chlorine in the presence of ultraviolet light to give us benzene hexachloride. Let's look at the uses of benzene. These are the possible uses of benzene. Thank you very much for clicking on this video, and thank you very much for watching this video to this extent. And don't forget to click like, subscribe, and click the notification bell for subsequent videos. I know